I'm Frank Ross,
I'm Joshua Houston.
and we performed a finite element analysis of a bicycle.
Our project goal was to design a bike that can safely support a 400-pound load. Separate parts with different parameters like materials and size were analyzed to keep bike failure to a minimum. A static analysis of the frame was performed where the front end of the frame is elastic support and the rear is fixed. A 2,000 Newton load representing a person is applied to the top. After testing aluminum, steel, and titanium with varying tube thicknesses, a aluminum frame with a 2 mm thickness is the optimal combination. These charts show that titanium is the superior metal for our frame, but due to the cost of titanium, we went with aluminum. Due to thin walls, buckling was a concern. After applying the same boundary conditions to the frame and conducting a buckling analysis, it was found that the bike frame won't buckle. The bike rims were simplified down to an 8-spoke rim made of 1060 alloy aluminum. After performing a static analysis, the bike rim will not fail, and each rim is capable of supporting a 330-pound load. Initial design surpassed expectations, even with fewer spokes, and no further iterations were needed.
The bike spring is one of the most important parts of the bicycle because it allows for intense traversing through rocks and yet keep the bike stable. 3 iterations of the spring were created. One was alloy steel, one was silicon, one was stainless steel. The alloy steel was the iteration that was our final spring because it featured a yield strength and a maximum stress that had a very significant difference as compared to the other two. Where the second iteration it failed, and the third iteration it had an issue that it was very, very close to the yield strength. After deciding that the alloy steel spring was the best one, an SM curve was created, and the SM curve shows that even with our spring being at its max measured stress value, which was 274 megapascals, it was still below the SM curve, so we do not have to worry about it failing due to intense usage. We also performed a closed form analysis on the spring with a 200 Newton force and max displacement, which is 4.78 millimeters, and it gave us a spring coefficient of about 41,823 newtons per meter. In addition, we did a closed form analysis for the frame using a beam and the regular analysis. With the beam analysis, the stress number was a lot lower, but the maximum displacement number, which was a lot higher, and the buckling factor of safety for the regular and the beam can be shown here. In conclusion, the spring iteration that was the final one is the alloy steel material with a 3.625 millimeter radius. The aluminum rim provides exceptional support, and for the frame, the one that is the go-to is the aluminum frame.